All right, I'd like to welcome everyone to the 63rd EOF Implementers Call. It is the 11th of December, 2024. This will be the last call of the year. Nobody wants to come into a call on Christmas Day, especially me. So we're going to cancel that one. And the next meeting will be the 8th of January. So here's our current agenda. We're going to talk about clients compilers, then we're going to do spec updates. First, EIP 807834, talk a little about the EOF metadata section. Then we're going to talk about generic factories and deterministic deployments, which was a discussion request from Frangio, and probably EOF create hashing. Those two might collide together. So we'll talk about 7765 tracing changes, lateness spec updates, and then do testing updates afterwards. And I have some stuff to show for some of the work I'm doing on EOF execution fuzzing. And if there's any other items people want to discuss, feel free to add them in chat and we can get them slotted in. All right, keeping up on chat. All right. So first, clients updates and compiler updates. Do we have anything from Charles? Anything from Viper?
Nothing on the compiler side.
Okay. Let's see, who do we have represented? Besu, nothing's changed. EVM1, any changes in the past couple of weeks worth discussing?
Nope.
Do we have Ref on the call? It doesn't look like it. Do we have Geth on the call? Doesn't look like it. Do we have Nethermind? Not recognizing any Nethermind changes. Any Nethermind names. And Aragon. Any Aragon 2 people on? Okay. It's not surprising, not much has changed. All right. So next we're up to. Oh,
I have some update on Solidity. So basically the functionality is merged, and but now we are focused on fixing some minor issues and updating Solidity tests to fully be compatible with the EOF format.
Yeah, I mean, like we have like all the opcodes needed to generate code, and like we proceed, like Radek said, we're proceeding with like last changes to actually run semantic tests that kind of prove that existing code can work on top of EOF. And then we'll be proceeding to the next phase, which is basically finishing like remaining stuff and making it more stable. We're close to finishing the first phase, I'd say.
All right. Is that an accurate representation?
Yeah.
Okay. All right. Anyone that I forgot to mention before I move on? Franjo, you still have your hand up?
Yeah. So I am working on an assembler for both legacy and EOF. So I have a couple of questions. One is, are there any assemblers that already emit EOF code other than maybe like Yule on, maybe not on main, but on the nightly or whatever build works on that? That will be my first question, and I have another one.
Anyone know the answer to that? I'm not aware of any.
Okay, so that
what about Yule? Just want to say that I don't know of any either, but like we have assembly imports in Solidity, but just wanted to confirm, yeah, it does not support EOF yet.
Oh, okay. So there are currently no assemblers or compilers that emit EOF.
No, we need to lock the spec down. That's, I think, the big barrier.
Yeah. Okay. Okay, so that's good to hear. This could be a little valuable. And around this, as I design it, I have a couple of, questions come up. Maybe there is one that I want to focus on right now. The exchange opcode, which this is about like the text-based representation of opcodes, right? And maybe the exchange opcode is the most interesting one because conceptually it takes two values, which are two stack depths. But the way that this is represented in the bytecode is by the sort of like a base and an offset, right? The n and m are essentially represented as n and m minus n. So when we make a textual representation for this opcode, would you sort of show it in the same way as n and m minus n? Or what I think would be better, more readable, is to just write it as nm in the text, and then the assembler would actually do the encoding to what the bytecode actually expects. So has anyone thought about this? And would you agree with my thinking here?
I think it would make sense for it to match the semantics more closely. So the raw one, n comma m minus n.
Okay. Someone in the chat is saying the other one. So we currently have one on 1-to-1. Maybe I also think nm would be clearer. But although it's just really a matter of defining the convention, and then we will just all adapt. But
like, I think if it's closer to the bytecode, it's easier to debug. Like if you're reading it, and
possibly,
then do the calculation in your head or something. But if it's like doing some conversion, then you have to understand how the assembler is doing the conversion.
But
So-
how is doing the conversion much different from like a labeled jump and letting the assembler do the math for how big the
Yeah.
absolute jump is?
Yeah, and another similar thing is rjump v, which in encoding it has a number of jumpable items. So I would for rjump v, I would also like list only the offsets, not list in the first size of the table.
Yeah. So maybe it might make sense for me to propose a written textual representation that we can all agree on, so that whenever this is used by tooling, stuff like exchange and rjump are all represented consistently. Personally, I would prefer nm, because I feel like the role of a text-based assembly is to make things a little clearer. Technically, in the bytecode, it's not even represented as n or m minus n, because it's like n minus 1 and mn minus n minus m minus 1. So n and m minus n would already be a little bit of a difference from the bytecode itself. I think it would be good to go a little further and do that. So anyway, I'll put together a proposal next couple of weeks, and maybe we can center around that.
From Solid's side, I just wanted to add that we'll have basically the same problem because we'll have to output assembly. And we haven't discussed that yet, but personally, I probably also suggest going with clear representation, because like that's basically just internal encoding that's not like the clear number. So yeah, but just saying that we have no decision on that yet, so kind of unsure what we'll end up with. I probably recommend that the one we were suggesting.
Cool. Thank you for the input.
Okay. Anything else on clients and compilers? Usually that's the shortest section. All right. Next on the agenda, we have here's my agenda. EIP 7834. And EIP 78 3, 4. Here we go.
Yeah, so I just pushed the fix the linting and so on. It's been passing all well. Also the Ethereum Magician's link. Yeah, so far we got positive feedback, but not much feedback, to be honest. Yeah, I would love to hear if anyone has anything to say about this.
So one open question on this that I think we need to get right for this and set as the standard for future is the header ordering and the body section ordering. And I don't know what the right answer is, but as you mentioned in some of the rationale, we need to keep the metadata number to 5. So we're not changing any of the meaning of the previous sections where code is 2, types are 1. Wait, not, yeah, types are 1, codes 2, containers 3, metadata. Data is 4, so metadata would be 5. Do we sort the header absolutely by number, or do we sort it by container order? Because the container order, we have to have data section last because of various reasons related to appending data and making it easy. And there is a proposal to make kind data OXFF, and that's the other option, is to make it FF. So those are, I think, that's one class of open issues. And of course, the other class of open issues is this the appropriate thing to add to EOF? I'm in favor of it, but I'm not sure everyone is. I'm not sure that's an absolute 100%. So those are, I think, the two big issues. Anyone else have comments on this?
Does anyone know that EIP to make kind data FF?
Yeah, I've not seen any.
Do you want to make this a new AP or just update the existing AP? I thought existing AP would be appropriate.
For adding the metadata or for
No, for the FF.
FF?
That's what the question was about, right?
Yeah, FF. Do we want to just change that in 3540?
That would be my bet, but I'd like to hear.
Yeah, definitely not a separate AP for this. It's okay to
Yeah,
change
because
it. We decided.
because it's yeah. It also it has its own merit.
And one risky thing is that they already have Rhett's already started doing AlphaNets, so there might be code that has the 04. That is the risk.
But I mean, I would see this change also to fall into the category of changes that are done after the first devnet.
Right. Okay. Yeah, because we're not locked in yet. It's not the same level as if we actually shipped it onto Osaka and then changed it.
Oh yeah.
If we think this makes sense, we can also, incorporate it in current EIP or just the larger EIP, like to make data 0xFF to the metadata EIP or.
I don't think this is. I mean, changing the section index to FF has its own merit, so it doesn't have to be attached to the metadata section EAP.
Okay.
And then, I mean, if that ships, well, I mean, the metadata section EIP would need to be updated.
Right. Because we're already considering other incompatible changes like changing the order of EOF create.
Yeah.
So having incompatible Osaka 0 and Osaka 1 bytecode is something that's going to be happening anyway.
Yeah, I mean, we could have, I mean, no section index 4. That's also an option. But I think it's kind of secondary.
Okay, apart from the ordering, is there any other concerns about the metadata section?
I brought up some concerns in the Discord, just that just kind of makes the container format more complicated when it could be, for example, Viper doesn't have a metadata section in the runtime, which part of that is for the reasons that are actually explained in the rationale here. So like it's unreachable by the runtime code for sure because it's not there, and it also saves some space. I get the appeal of having some kind of section of the code that's unreachable and unreadable, but I just think it could also be addressed in other ways, such as having stuff in the init code, or I guess in the current way to deploy EOF contracts is through legacy contracts. So it would be like in the legacy contract actually. And then you deal with it through tracing or, via emitting events. That's another thing in the EVM, which is like unreachable and unreadable by contract code.
So what this init code data would be at the end of the data section is how you would handle it if we didn't have this? How would Viper do it if we didn't have this EIP?
It's in the init code, so it's not even in the container.
Well, the init code is the container. The init code is a container for EOF. It has to be a container. So we could, Viper could.
It like comes from off chain, right?
Okay, so, well, yeah, it would be on chain. You could have off chain and init code, but then you would have to have your off chain tooling to get the data, and it wouldn't come back on chain. The init code shows up in the transaction. The init code container shows up in the transaction, so it would still be on chain if we had it as part of the create transaction, but it would still need to be part of the container. Or it could be appended as extra data, not used as part of the call, I guess.
Yeah, so that's what I'm saying is that another option is for it to be an event, or
how would that make Sourceify? Would that make, is only having it in the init code, would that make Sourceify's job easier or harder?
Definitely.
Definitely what?
Sorry, definitely harder because getting the init code is like a couple more steps difficult than getting the runtime. Runtime is quite straightforward. Init code, you need to first have the transaction hash. If you don't have the transaction hash, you have to do a binary search over blocks, then run through the transactions to see which transaction has the contract. And even after that, if the contract is created by a factory, then you still need a trace. You need an archive node to get the transaction traces to be able to get the init code. So in general, I find runtime bytecode to be more proper for this kind of information. But I guess any kind of tooling can decide on put it in the init code container or run deployed container.
Yeah, so that's another thing I was saying is like you can make off. So it is a trade-off between, in Viper, we've made the trade-off between like runtime bytecode cost and tooling difficulty. But like another way of addressing it, like I mentioned, is to have an event for creations, and then you don't native search, which I don't know, the compiler inserts or something. But yeah, I guess I'm saying that it can be addressed with like conventions in application code rather than adding a new kind to the EOF format.
So even if we don't add it, that doesn't preclude compilers from adding their data to the data section, still keeping it readable. I mean, it doesn't preclude them from the practice that Viper doesn't want to do.
Yes. Right. Like I said, I think there is an appeal to having this unreadable section in the runtime code, but I'm wondering if there's like other ways to address it, because there are other solutions within the EVM that can be done for this.
At least from source code verification side, I find having a separate section particularly appealing because then it's quite straightforward to decode and where to look for metadata and for the data that we need to ignore. Because once you start mixing metadata with data or code, then the verification gets quite complicated. Then you don't know where to ignore when you're verifying. And again, as mentioned in the AIP, if that part affects the rest of the data or code, then it gets impossible to do the verification. So even there's a convention, that convention needs to be really well defined if we want straightforward verification.
Yeah, but like the metadata is already done by convention. And now that I think about it, I think the event solves some other problems with factory contracts. Like you don't need an indexer in order to find who deployed what and so on.
Okay. I think some of these should be addressed then in the rationale and security considerations of the EIP. Would any of these be blocking where we wouldn't want to do this? Or are these just improvements for iteration on the better way to use it? Okay, so I don't hear these as blocking. I think we just need to address these concerns then in the text of the EIP.
Sounds good.
Okay, next on the agenda is generic factories and deterministic deployments. I think Frangio posted this.
So I just wanted to think a little on this. And I think it might be related to the counterfactual deployments that, Dano, you have been asking about. So on Ethereum, there is apparently a use, and like developers have become accustomed to and like and sort of demand deploying contracts on the same address on multiple networks. And especially now we have many chains, right? I'm not convinced that this is actually valuable personally, but a lot of people do believe that and use this. So many protocols like, I don't know, Uniswap is running a competition even now to get like the coolest address that they'll use on all networks for V4. There is no real mechanism to do this on these chains. So what people use is what's known as Nix trick or deployment method, where you kind of mine a signature for a transaction by trying random numbers. I don't remember exactly the structure of the procedure. And in this way, you can get a transaction with like signed by an account that you don't have the private key for, and you can send this transaction to all chains and theoretically and deploy it. So this relies on the old type of transaction where it's not bound to the chain ID, and also it relies on some assumptions about like fees, because in the transaction for which you will mine a signature, you need to include the fee parameters. And so I haven't looked exactly at how they do it, but I assume you just set a very high gas price and assume that it's going to work. So this is like many considerations, things you have to do to get this to work. So what people have done is to use this method to deploy factories, and then you use those factories to deploy without having to do all that thing. So there are many of these factories. You may have seen the one that comes to mind now is CreateX. If you go here, you can see sort of some of the motivation and all of the work that has gone into it, and all of the sort of requirements and many functions they've added to the interface for those requirements. So my point that I want to raise is this kind of factory contract which is generic. As you can see, it receives, it's like function deploy create, it receives the array of bytes that it'll just pass on to create. So this kind of factory contract is not implementable in EOF. And so this sort of implies that there will be no method, well, I mean, other than mining these signatures to deploy contracts at deterministic addresses. And well, again, so yeah, it seems, I don't know how you guys feel about this. If you've thought about it, and also if you are considering, I haven't looked at TX Create. I don't understand for when you think that will be scheduled. I understand it won't be in the next fork, but I think this is something we should consider.
Yeah, I'm here as a application developer who depends on that behavior, and not only that behavior, but also the ability to create contracts in an unsalted fashion. Because if you have both salted and unsalted creation, then you can deploy contracts in such a way that they don't depend on their bytecode, but then do depend in a non-sequential way on some external data. And then so that pattern gives you a way to both securely and flexibly deploy contracts to predictable addresses on different chains, or the same address on different chains. In a permissionless.
Can you describe again what you mean by unsalted?
So the salted creation is the create to style, and then unsalted is the older create style, where it depends on the nonce.
And you have a use for both?
Yeah.
And when you do this, do you use this kind of generic factory, or do you use the signature mining method yourself?
We would love to use the signature mining thing. We found it to be a little bit brittle on some chains that have what I would call unreasonable gas rules. The problem is that if you don't use the signature mining method, then you end up having to depend on somebody else's infrastructure to, toe hold your stack, which is also a problem that we've encountered. So, yeah, there's no perfect solution. I mean, if there were a EOF enshrined perfect solution, we would adopt it immediately.
So I should mention there is an alternative to this kind of. So the CreateX factory was deployed using Nick's method. So this kind of signature mining method. There is an alternative, which I think is the one that Gnosis uses. which is they have a private key and they sort of they take care of deploying on each network when needed. And in this way, they're not bound by the gas thing, but the availability of the factory on new chains becomes reliant on Safe doing this for it. Charles asks, what the exact reason CreateX is not implementable in EOF? So in EOF, you can only create contracts using EOF create that you have declared in your container, right? Or is there a workaround for that?
Yeah, I see what you're saying. So basically in EOF, you would need to like separately deploy the factory contract and then ask CreateX to like run it for you, right?
You could delegate call in if we do the EOF create. But then you'd have to have it deployed on chain by a second transaction before you could actually deploy it.
Yeah, so this is the other reason why I wanted to bring this up, because it affects the design of EOF create's address formula. So if we want this to be, if we want CreateX to be doable in EOF using delegate call, then we need to see what is the address formula that enables that.
Okay.
Yeah.
So probably a quick sidebar into what TX create does. A lot of description here, but it allows you through an opcode to reference a contract that is in a transaction. So this preserves the code introspection aspect, in that you don't need to know the contract, but you would go and you would give your TX create, and you would have either an index or a hash. You'd have a hash into your transaction. That hash would be in the transaction. We need a new transaction body type. It's where it could carry these various. Where's the specification for the transaction type? It's where it could carry these various the data. You have future upgrades, but you would put the contract in your transaction. You would call the factory, and it would reference the contract in the transaction, and then use its local value to create the hash deterministically. And I think EOF feature upgrades. So I think this is probably the best description of what's going on for what we have planned for TX Create. It was cut from Pectra for complexity concerns. And depending upon when Osaka ships, I could see it returning. If Osaka slips in at 26, I'm probably going to pitch it be added for the first revision. But if we're actually going to be disciplined and ship it before DevConnect, then I don't know that we have room to put it in. So there's a couple of issues going on there. So it might need to wait until Amsterdam to really get this fully working in parity with the existing thing. And I agree with Duncan that we need to have this use case fixed for EOF, where people can bring in arbitrary contracts into fixed known addresses if they have the right toehold.
Okay, so TX create enables generic factory contracts.
That's the goal. And I think there's a way with delegate calls, we could write one that we could do it without TX create, but it would require a two-step deployment.
Yes, I need to think about that, but it enables factory contracts. This doesn't by itself solve deterministic deployments, because you're relying on a factory that has the same address on multiple networks. But
right,
no,
you
I don't
still
think
need to
this
get
is
the toehold via Nix method or EOA. You would still need to get a toehold.
Yeah, so I think it's not the job of EOF to solve that, but I do think Ethereum should have some reliable way to do that without the signature mining trick. But that would be out of scope for this work group.
And then before we move on to the next thing, there's also the question of unsalted factory deployment, because without an EOA, deploying a contract, there's no way to get a nonce-derived contract address. Both TX create and EOF create are salted rather than nonce-derived.
Can't you just solve that in the factory contract? It maintains the nonce manually.
Both of these opcodes create addresses the same way that create 2 does. And so ultimately, the address of the deployed contract depends on its init code. So if you want a contract that does not depend on the init code, the address does not depend on the hash of the init code, you are stuck either doing something crazy with EOAs and like slashing or some kind of game, or giving up, because even Nick's method creates addresses derived from init code.
Yeah. So I've mentioned this on the relevant issue. I forget the exact number, but I'm pretty in favor of removing the witness entirely, and I think that just solves all of these problems. Like there's the problem with createx. If you didn't have the witness, then there's no issue there, I think. Correct me if I'm wrong. It also solves the gnosis safe issue where it's really hard to get the same address on different chains. And it also solves this issue because then the hash for the deployed address is just based on the salt, which is whatever the factory chooses.
So the witness is the hash of the code that we're putting in?
Yeah, there's been several witnesses that have been proposed. Well, one is the init code, which I think has been kind of rejected because in EOF you're not supposed to be able to introspect code. And then the other ones are like the code address, so like the delegate called address and the init code section index or container index.
Yeah, that makes counterfactual addresses more difficult. Does it make them impossible?
No, it makes them. No, it's not impossible, but you have to. I spoke about this with Piotr, and basically you have to trust the contract that deploys the that calls EOF create. So basically, there's 2 cases. If you're an EOA and you want to ensure that something is deployed at that specific code is deployed at a specific address, then you basically rely on a factory that will respect the hash that you give it of the code or something. And then the other case is on-chain. Sorry if that's not clear, but like maybe I haven't had enough coffee. But basically the other case is if you're on-chain, then you can't introspect code anyways. So like you can't do the counterfactual deployment. And with create 2, there's a very important property, which is that you can compute the counterfactual address in your code in the like on chain, but because EOF create removes code introspection, there's no possible way to do that if there's a witness in the deploy in the hash computation.
So what if TX create, you created a factory where the TX create used the TX hash for TX create and required that to be the salt? Would that solve the counterfactual problem? Because your salt would be fixed to your address, so you could only deploy it with one address. So you could then only deploy one possible code to that address. Is that the core of the counterfactual issue?
That fixes the counterfactual issue, but then it opens up the unsalted issue again. I think
right.
The clever solution is the factory gets to specify the salt or the witness as whatever they want. And then if you actually want counterfactual, you have to make sure that the factory doing the deployment is inserting the witness as the hash of the init hash, or as the hash of the init code.
So are counterfactual and unsalted compatible? I don't think they are.
No, I think if you do the thing that I just suggested, I think you can get both. It's just not the way it works right now, and it's a little bit tricky.
Okay.
It's kind of a break from create two semantics, but I think it pushes more responsibility to the user to like not have a collision, but it preserves the important property, which is that somebody else can't like force you to have a collision, which is I think more important.
Okay. I think we need to time box this because we still need to talk about testing. I don't think we get to a resolution switch state anyway. But yeah, these are all great things to think about as we talk about the hashing for EOF create. And I'm probably also going to skip over, since it's related, the where's my agenda? Skip over EOF create hashing. Would it be okay if we skipped over the code size EIP, or do we want to discuss that for like 5 minutes? Or can we push that off to January?
I can just give my feedback real quick, which is that I think it should be accompanied, as I said in the comment, the code size limit change should, I believe it needs to be accompanied by the relevant format and opcode changes. Otherwise you have like inaccessible code where you have to like do this weird thing where you chain jumps together. Yeah.
Okay. We'll discuss that more in depth in January. But let's talk about testing. Mario, do you have anything for testing?
Not particularly. We have been working on DevNet 5 so far. I see that there are some outstanding PRs for EOF. I need to get back to those probably. If you give me this week, I can try to finish them up. Otherwise, if there's anything urgent for me to review, just let me know, and I can try to prioritize. Yeah, but yeah, not apart from that, not that much. Yeah.
Okay. Cool. That's easy for testing. So a couple of things that I also want to talk about for testing have to do with fuzzing. So the first thing is I want to discuss is some of the proposed changes I have to the trace specification. When I have a new version set up, I need to fix this sample here. But the big changes here, I think that this goes out to all of the clients, is the PC equals 0 handling for, and I think my notes here are going to be better. So the first big change is we need to have an agreement on what PC we're going to use for all of our trace semantics. And based on fuzzing, we either need to include the section number into the trace, or we need to set the PC equals 0 to be the 0 of the container itself. Because we need to be able to, and if we have the PC equals 0 and have it be the absolute index within the container, then we don't have to enumerate which section we're executing as part of the trace. It'll be clear just from the container itself. So that's my one proposal, and I have Besu has that. My get fork has that, and then changes I put into Nethermind has that. Right now, ref does PC equals 0 for each code section, and EVM1 does PC equals 0 for the first byte of section 0. So that's what I'm going with there. So like feedback on that, either in the ETH Magicians discussion thread about it, or yeah, feedback on that. But my experience with that, because where this is coming from is I've written a fuzzer that is not much so far. It only does about 4 things. It increases, it adds a push and a pop instruction, and it changes push contents right now. But from this, I've been able to actually find 3 implementation bugs in 3 different clients so far. Base2 had one, Geth had one, Nethermind had one. And I haven't been testing EOF, EVM1 and EOF ref yet because I don't have a trace statement that actually works for them. I suppose I could turn off the trace and just try off the end hash and see what we get there. But getting fuzzing is going to be essential to getting the comfort from the other core devs that what we've written is stable enough and won't cause consensus issues. While there may be no spec issues, we want to also get rid of implementation issues. And fuzzing is the best tool we found in addition to reference testing to get these fixed. Another interesting point that I probably want to make here is the corpus I'm using for the fuzzer right now. I don't generate a corpus from zero. I'm using the corpus from the reference tests. I run the reference tests in a mode where there is a single test per file. It takes forever to generate this, but it creates a very valuable basis to do a lot of these changes because a lot of these bugs that we're finding are just one-off from a test. So that's a quick overview of what I'm doing with fuzzing. Any comments, questions from clients, from developers? So I guess another thing I want to point out is one of the changes I'm doing. I'm also in the spec doing some quality of life changes. This is the old 7756. Darn it. So I do have some changes in the tracing. Darn it. So here we can see, I also changed the OP to become a hex number and the gas number to become numbers. And I also included flexibility that people reading this should expect numbers could possibly be hex encoded numbers. So this, I think, increases the readability. So when we get to some of these opcodes we know by like F9 as XC delegate call, it's a lot easier to read than like 250 or whatever, 248, whatever that corresponds to. Because there's a lot of magic that goes in with corresponding like 61 we know is a push 1 from reading these. And then we get to gas and seeing that the gas differences, it's a lot easier to do the math when there's a problem and seeing that the difference is 2500 rather than having to whip out your hex calculator, do 2 conversions and do a delete. So those are some other changes that I have for quality of life for end users. But I've also indicated in there that clients reading these need to accept both. I have Go EVM Lab patch out there that handles that for OP and all the gas already. And I think the Go EVM Lab already handled some of that. Okay. We have 6 more minutes in the call. Any other discussions we want to have? Perhaps I time boxed the hash discussion early, but thought we'd have more back and forth on testing. Can anyone still hear me?
Yep.
Yes.
Just no feedback. It's also good to me.
I wanted to ask about the generated fuzz tests. Is there a sample that we can see, or that you can share?
Sure.
The generated tests.
If fuzz. Let me show you. I think 31's got one that's got a failure. So here is like a typical. So Go EVM, you run it in batches. You create a set of a corpus, and I delete the stuff that's not kept. That one had a good pass. 39 had a failure. There we go. So when Go EVM has a failure, it spits out the test case, it fails it. And from this in the tool, I can parse the output and save the file. And if we follow the same, if we turn tracing on, it'll tell us exactly where the difference was handled. In this case, there is a pricing issue with Nethermind. They're charging 950 more gas for some reason I don't understand yet. And we see that the EXT delegate call was the operation before and after. Now this can be somewhat deceptive because we don't have the memory in here. One of the bugs that I fixed in Besu, the problem was that it wasn't doing the memory expansion correctly for previous calls. So a further call down the road would have the incorrect gas call amount because memory expansion wasn't done. There are some cases where, like, in a failed call, you still do memory expansion. So this is generally helpful, but really what happens is you go back and you look at the entire trace that it creates. And this, it normalizes the trace into something that it can run a diff against. So here, Besu and Geth would just be absolutely the same. And it's when you get to the Nethermind that this value would be different. You run this under plain old text diff, and this is where you would see things are different. And it's still using the old OP numbers. I'll probably update that to use hex here pretty soon. But you can see the state root's different, 2352. And this is 41DA. I sorted accidentally. Here we go. 41DA, 41DA. So these, so Besu and Geth agreed on it, and Nethermind was the odd person out. And so the tests that are generated, they're just state tests. And what I do is I go and I find all of the EF0001 EOF codes, and I do my mutations on each and every one of those. I do one mutation. And I keep a log of the mutation things I do. They're not exact, but set a push to a random and block 0. And a bunch of, add a push pop, random. There's probably a magic value, push magic value, set address. Address, I got some good stuff there. But another thing worth pointing out in the way that I handle this is when I parse the EOF, I do more than just parse out sections. I parse out basic blocks, which is a compiler optimization step where you take all codes that do not branch and he puts them together in a basic block, and then he puts some notation to say this basic block flows onto this one or it branches to this one based on whether it's a jump or not. And so within those basic blocks, I'm able to add and remove code, no problem. That's why I did the push 0 pop, is I was changing the size of these basic blocks, and I could go back and I could reconcile the absolute positions of the relative jumps. And I think that's one of the problems with just having a plain old updater that just manipulates and changes the bytes or inserts random bytes. You're not going to get the same frequency of valid EOF code. And that's another complication that's presented in the fuzzing here, is all the code that's fuzzed has to be valid EOF code. So once I do that manipulation on the blocks, I do a reconcile step where we repoint with the relative jumps. We also make sure that the jump heights are correct as well. And if the jump heights are incorrect, we throw it out. And I still, right now, I don't have it perfect, so I bring in the EOF code and I do a validation of the code. And if the code doesn't validate, I pitch it off. So there's no mutation if it doesn't come back as valid. But this is, it's EOF presents some complications to traditional fuzzing, and we just apply stuff that's worked before. It's important to note that this is not a new approach. Google did something similar to test eBPF. They created a validation-aware fuzzer that would only do valid fuzzing things. And from that, they were able to find the ePBF bug that was on Hacker News a few months ago. So this is not it's not a novel technique. It's been done before, and it's shown to be successful. So. Cool.
Are you happy with the approach so far, or with generating, for example, input for an assembler, and then, which is easier to ensure valid, and then assembling that into bytecode? Would something like that be helpful?
We could do it in an assembler too. We would need to write the assembler and integrate it in. I'm manipulating the bytecode directly and then reconciling it. The reconcile stuff also, I forgot, we need to track the stack height in the inputs and the outputs as well. So the reconcile also helps calculate, and that's stuff the assembler would help out with too. So yeah, fuzzing directly into assembly input would be another possibility of how we could write the fuzzer step. I'm happy with it right now, but I haven't written the more complex ones on my hit list, which is stuff like add a new code section, create new code blocks, assembly EOF from code, I already got that. Add arbitrary operations, which is something I need to do. Remove operations, add branch, collapse section, and move a section out to another, move a section of the block out to another function. These are, kind of inspired by an old Scientific American article where they're creating computer viruses in memory and creating an ecosystem. Some of the stuff is way back in the 80s. But I've always, some of those techniques there were just generally useful in building some of these things. So some of the mutations. And the goal is to finally get up to parity with fuzzy EVM. Fuzzy VM Marius's project, where we could do all the mutations they do, just do it in EOF. But do it in Python, make it part of the ETH framework is the goal. We're over time, so I will go ahead and let people go. Our next call will be in a month. Again, if you have any comments, feel free to comment on the Discord. Feel free to comment on the ETH Magicians threads for these EIPs. And I'd like to thank everyone for the time they spent in working on EOF.